computational graphs. In the last video, we said automatic differentiation breaks a complex function into simple operations. But how do we organize these operations? The answer is a computational graph. A computational graph has two parts. Nodes represent operations like addition, multiplication, or exponentiation. Edges carry data, the variables and intermediate values flowing between operations. Data flows from inputs on the left to the output on the right. Let's build one for a concrete example. Take the logistic regression loss for a single data point where y equals 1. The loss simplifies to negative log of sigma, where sigma is 1 over 1 plus e to the negative z, and z equals theta 0 plus theta 1, x1 plus theta 2, x2. This looks complicated, but we can break it into elementary operations. We start with the inputs on the left. Theta 1 times x1 gives f1. Theta 2 times x2 gives f2. Adding f1 and f2 gives f3. Adding theta 0 gives f4. Multiplying by negative 1 gives f5. Taking the exponential gives f6. Adding 1 gives f7. Taking the reciprocal, 1 over f7 gives f8. Taking the log gives f9. And finally, multiplying by negative 1 gives the loss L. 10 nodes, each doing one simple operation. Now let's plug in actual numbers. Set theta 1 equals 1, x1 equals 1, theta 2 equals 2, x2 equals 2, and theta 0 equals 1. Follow the computation left to right. f1 equals 1 times 1, which is 1. f2 equals 2 times 2, which is 4. f3 equals 1 plus 4, which is 5. f4 equals 5 plus 1, which is 6. f5 equals 6 times negative 1, which is negative 6. f6 equals e to the negative 6, about 0.247. f7 equals 10247. f8, the reciprocal, is about 0.9975. f9, the log, is about negative 0.247, and the loss L equals 0.247. A very small loss because this model is quite confident. We have built a computational graph for logistic regression loss and computed the forward path with real numbers. Every intermediate value is stored on the edges of the graph. In the next video, we will use these stored values to propagate gradients backward through the graph. That is backpropagation.